Everybody, and thank you again for joining us this morning. Today we're going to go through a presentation on sort of leaks, repairs, and actually how we identify them. If you've seen any of the information that we've been putting out about promoting the webinar, you'll know that actually a small 5 litre per minute leak can lead to a £5,000 bill at the end of the year, and that's made up of obviously the water that is lost, as well as the fact that you probably get charged for it as well because of the mechanisms on the way that water gets billed. What we're going to do today is a little bit of housekeeping. So everybody's on mute. That we know from experience works best. On the right hand side of your screen there is a little sort of drop down box, and within that is a section with questions. So if you type a question in there, that'll pop up on my screen. And what I'll do is I'll ask Paul, who's our expert, to answer those questions at the end. Other than that, everything should hopefully go smooth. You should be able to see us. I know this is a thing that if you've been doing plenty of VC meetings, this is what happens all the time. Everybody, can you see my screen? Can you hear me clearly? I'm going to take that out if you can. And what I'm going to do first is I'm going to take you through a little bit of information about who TWS is, where we sit, who we are, and then from there, Paul's going to take us on to some information about leak detection and how we repair those leaks. So just bear with me a second. So who are we? We go by a lot of names, but if you've worked with us in the past, you should know that we're Northumbrian Water. Northumbrian Water is a water company which operates in the northeast of England as Northumbrian Water and the southeast of England as Essex and Suffolk Water. The Essex and Suffolk and the Northumbrian Water are trade names, and the legal entity is NWL, Northumbrian Water Limited. Underneath that, we had a varying different number of names over the past few years. So you may notice there's things like AES, Northumbrian Water Scientific Services, Northumbrian Water Pipeline Solutions, amongst a whole raft of other things. So you can see this this little flow diagram there. So the NWG represents the legal entity company, and then you'll be familiar with those brands if you're based in our sort of water supply areas. In 2017, there was the deregulation of the water market, and to pull everything together, basically what we did is we did that. So Total Water Solutions sits over the top of Pipeline and Environmental Solutions as just an overarching brand, and it's a way that we can kind of have one website and sort of one marketing function to let you see everything that we can do. And then I'm going to pass you over to Paul, who's going to take you through the repairs and renewals section of the presentation.
Thanks, thanks, Andy. Sorry, flogging my throat there. So I'm the Pipeline Solutions Manager, which sits inside TWS, as Andy's just explained. And I'm going to take you through a few sort of issues and ways that we can work and ways that we do work. So we'll start off with slide 1, and that's clamps. So one of the best methods, obviously, is a repair clamp. It saves time, money, reduces disruption. We all know pipes come in lots of different sizes, and that can make things challenging. For instance, lack of stock, special orders required, bespoke fabrication. So it's not all straightforward. I mean, here in the picture you can see Northumbrian Water fitting a large diameter encapsulation clamp. This method is used when an original clamp has failed or a joint has an unrepairable leak, you know, so it's really difficult to cut out. It'll save a lot of time and money to use this clamp, so that's one of the repair methods that we carry out. The encapsulation clamp will do what it says on the tin. It'll encapsulate the original clamp or joint and stop the leak for many years to come, because they're really good, strong, well-made clamps. You know, they're great for large diameter mains, and this method is used when a pipe renewal or cutout is not a viable option. So next slide, please, Andy. More on clamps. We've got the common repair clamp, this one here. There's no need to turn the water off. It can be fitted live. They have a 50-year accelerated test, which gives it a 50-year life expectancy. So the stainless steel bolts coated with dry film lubricant provides excellent corrosion resistance against degradation and maximizes its long life. Accelerated aging tests, like I've just said, AAT they call it, have verified a 50-year design life expectancy on our own stocked Viking Johnson clamps. These are the best on the market. You can't just pick these up from the shops or your favorite DIY store. These are special order for the water industry, and this is what we use. Next, please, Andy. So we go on to difficult repairs, and as you can see highlighted here, we've got some real issues in this excavation. So due to the unknown nature of underground leakage issues, we always include a few assumptions and provisions within our customer communications prior to us doing any work, because it's basically a lot of unknown under there. I mean, as you can see from this picture, what lies beneath ground level can be a complicated mix of unknown pipework, large concrete structures, and in some cases water mains encased in concrete. You can see that here. Once uncovered, these issues make for a challenging and sometimes dangerous works area. At NWG, we have the experience and skills not only to mitigate risk, but also to put in place innovative solutions to unexpected complex underground issues such as this. Specialist tools, above ground temp pipe, rerouting, we can do all that while we tackle things like this. So although these are really challenging, we have ways and means to get around it and get things back in order. Next one, please, Andy. So here we've got the standard cutout repair. The cutout repair, it's mainly used when clamping a main or a leak is not an option. So you've seen the clamp earlier. When that's not an option, if you've got a longitudinal crack, which is long ways, then this is the best option. You cut that out, do away with it, clamp it up. Such as large longitudinal cracks, what I've just said, in the pipe work, which cannot be fully encompassed by a clamp. Sorry, easy for me to say that. Very poor pipe condition at ground at or around the leak point is another reason why you'd use this. Once the length of a cutout repair has been identified and the existing water main cleared, this method of repair is another very reliable repair method. Again, Viking Johnson, best on the market. That's the clamps we use. Next one, please, Andy. So here you've got a way of replacing your mains, and it's called pipe bursting. It minimises excavation, replaces pipe in the exact same position, so there's no need for new plans to be drawn up, no trenching, and minimal reinstatement. So you don't have to dig a big long trench to put this main in. What you need is an excavation at both ends of where you want to go with the pipe, and do it from there. It saves a hell of a lot of reinstatement costs, shall we say. So pipe bursting is when a new pipe is pulled through the existing or old water main. With this method, we can replace the old pipework with the same size new pipework, giving customers the same or even better flow rates than previously experienced, because old mains are furred up inside, so you get degradation of flow over a long period. So this method actually restores your flow rates. It also dramatically cuts both excavations and reinstatement time and costs. Next, please, Andy.
Paul, just quickly on a question on that one, is that the sort of thing, if you think of where maybe they've got like a main road coming into a site where obviously you would, traditional trenching, you're going to have to stop that road and you have to stop them going into the site. Is this a sort of a solution that you could use to kind of effectively pull it through underneath the road, and therefore they don't have to stop what they're doing, I guess, for
absolutely, Andy. This type of works is used to go under motorways, heavy main roads, sites that really can't shut the roads down, like a distribution centre or something like that. So what you're doing in that case is obviously you put in place pipe bursting or slip lining, so that you don't have to do all the excavation. You can keep traffic flowing. You can just pull it straight through the old main, and that's it. Job done. Yeah.
Brilliant.
So we move on to directional drilling, which is another method, Andy, that can alleviate issues, what you've just been talking about. So, I mean, the directional drilling of a new water main can be very quick and cost effective. As you can see from the picture, that's a narrowed down sort of picture, but you can do long distances with directional drilling in ideal conditions. This method of building a new water network or replacing an old one only requires launch and receive pits at every 100 meters. So again, under roads, along sites, you can really minimise the disruption of a site or a road. So that it makes it the ideal for busy sites that want minimum surface disruption while gaining a more reliable and robust water network. So next one, please, Andy. We've got leak detection techniques next. So yeah, this is the stick. So back in the day, this is what it looked like to spot leaks that surfaced. This is what the guys used to do. There were only two main options really: the stick, what we call the listening stick, and to spot them as they come out of the ground, which is not ideal because only about 5% of leaks present at the surface, and most are not directly above the leak anyway, due to ground conditions. Water company inspectors could be seen regularly working together, just like this, in order to narrow down a leakage area. Not ideal, especially when these guys are in the centre of London, so there'll be a lot of background noise that they're trying to listen through to try and hear leak noise coming onto the path. Next, please, Andy.
I was going to say, Paul, with that one, when you were saying the leaks don't come to the surface, how do they just naturally soak away into the ground? What happens?
So most leaks will find a way. The easiest path really to get away and disperse. So most of the time, it's about 95% of the time, I think, leaks will just fall away underground, rubble, paths, cracks. They also go into drainage systems or sewer systems. If there's a crack in a sewer system, they'll normally find a way to that and disperse into a sewer system. So you'll never really know that you've got a leak unless you're looking at your bills. If you're on a private site and you notice a massive spike in your costs, that can indicate a leak. So yeah, it's very difficult to know there's a leak there unless you're really on top of your water system and you know what you should be using and what you should be charged.
Yeah.
So yeah, as you can see, this next slide, it's the stick again. Not much has changed. It's a modern invention. It's still the first tool in a leak technician's box really that he'll reach for. The stick has stood the test of time, although it might be made out of a different material now. Some of them metal, some of them are wood. It's still there, and it's still the first point of call. It still serves its purpose, but it's better suited for small to medium mains leaks really, but not ideal for commercial leak detection where sites tend to be very noisy. Plastic, very difficult to hear leaks on plastic, especially if you're above the ground trying to hear a main underground. They don't give off much noise. So this really, it's a good tool to start off with, but it has its limitations. That's why we're a technical outfit now.
Yeah.
Next one, please, Andy.
Sorry, another question. It's just me asking you questions all day today. Sorry.
Right.
So when we're talking about sort of plastic pipes in the ground, and obviously it's difficult to get I imagine it's vibration, the sound off it. What's the kind of this might be a difficult question. What's the kind of proportion of the pipes in the ground that are plastic? Is it most of them nowadays? Is there still a fair amount of the metal ones?
In our water networks, so that's what brings water to your households, in the street, along roads, stuff like that. A lot of that is being replaced over the years with MDPE, things like that, which is obviously plastic. So, but when you're talking about private sites, it's quite low. It's a quite low percentage that are plastic now, because sites that we deal with, say British Steel, a large chemical plant or something like that, they have legacy pipework and legacy buildings, legacy everything, and the pipes are no different. So they're all mainly cast iron or something like that, or ductile iron, which is obviously coming to the end of a lifespan nowadays. Is 2020. You know, these will have been put in 50 years ago, 60 years ago when these sites were brought into production. So yeah, there's not a lot of plastic on private sites, which is which is a lot less challenging than if there were plastic, because, like I say, it doesn't give much leak noise off, whereas metallic pipe work does give leak noise off to a higher proportion.
Right.
So we've got in the beginning they were big next, and we're not talking about the stick. So this is a correlator, which is what we use to listen for leak noises and pinpoint leak noises. So this was a huge leap forward in leak detection back in the day in 1979 when the first correlator was produced. You know, however, there were huge, cumbersome. Batteries were terrible, not that accurate. You know, and the cost of this was the same as two small family cars. And for reference, you know, that Fiat Strada there was about £3,500 back in the day, or about 18 to 19k in today's money. So this correlator will have cost in today's money around £40,000, which at the time, you know, for what it was capable of doing, was quite a high price, I'd say. So yeah, next please, Andy.
What sort of a price is a correlator nowadays, Paul?
You're talking about, depending on what package you want, you're talking around about £3,500 to maybe £6,000, because you know, like everything else, there's add-ons to correlators and more technical correlators and, you know, things like that. So about 3.5 to 5 or 6,000.
Good reduction in cost. Still expensive, but good reduction in cost.
Yeah, well, we've got better at making them quickly. I think that's what it is.
Yeah, absolutely.
So leaks, they all count. As you can see, no leak detection required here. You know, these leaks can occur at any time, but most of the time they're associated with really, really cold weather, or when we have extreme dry periods in the summer months, because there's movement of the ground underground as the ground actually shrinks and moves slightly. So obviously you've got water mains underground. When the ground moves, the water main moves with it, and bang, you can see there that leaks in Gateshead. This is actually one of our teams out trying to get control of this burst. But yeah, that was a bit of an emergency, obviously, and it took a lot to get that under control and back up and running. But we did it, as always.
Is there I've heard a thing, I don't know if it's necessarily 100% true, but they kind of say that when it comes to sort of cold, tends to maybe have more of a play on smaller size pipes, whereas the long periods of dry has more of an impact on the bigger pipes. Is there truth behind that?
Yeah, absolutely. Yeah, smaller pipes obviously succumb to freezing a lot quicker than mains do. There's larger flow going through a main usually, whereas when you get your small pipes, they're often shut off for hours at a time, like overnight when you're in bed. So there's no movement on those pipes, so it's a lot easier for them to freeze. So yeah,
yeah, that makes
always
sense.
like your pipes.
Always like your pipes. Tip number one. There you go.
So next we've got quite a large leak. You know, the surrounding area has been washed away. It's an underground cavern that nobody knew about, and you know, this is what damage a leak can do if unchecked. You know, and a lot of the times, like I say, on private sites, unless you know exactly what's going through your meter and what should be going through your meter, then things like this can occur, because you'll get the ground just washed away underneath. A lorry or a tractor then drives over it. Something like this can happen. You can disappear down it, you know. So just remember that only 5% of leaks show themselves at ground level until you get to this point. You know, this is a mains burst. However, smaller leaks can cause damage such as this, particularly over a long period of time if unchecked. Yeah, quite a nasty leak, that one. Next, please, Andy. So I've got a question for you guys. There's a leak at a normal network pressure of 4 bar. The leak is on a water main, and the hole which water is escaping from is a diameter of 6.5 millimeters. So pretty small hole. How much water will be lost in 1 year? And I'm going to take a drink while you think about it. Next slide, Andy, please.
I was going to say, there's no answers coming through on the questions thing, and I'm going to leave you to explain the answer on this one as well. So we'll go to the next slide.
So it's 17.9 million litres, or 7 Olympic swimming pools. So that's a hell of a lot of water. Just think about how small that hole was in the pipe, and you know, if left unchecked, that water's gone. You're paying for it, and also it's going to cause damage underground on your site. So unchecked leaks really do need looking at. Yeah,
It's
absolutely.
It's a lot of water lost as well when you think of it from a kind of just precious resource, pressure on sort of water generally. Yeah, we can't really be afford to.
Yeah, absolutely. I mean, you know, water production within our company can ramp up to cope with leaks, but
yeah,
you know, customers are paying for it. It's an environmental issue. You know, these leaks should be checked, monitored. You know, all sites should be monitoring leakage. Next, please, Andy.
Yep.
So there you go. So a 6.5 millimeter hole equates to a loss of 17.9 million litres a year, and then you've got a 3.2 millimeter hole, and that's going to give you a loss of 4.5 millimeters. Litres, 4.5 million litres per year. You've got a 1.6 millimeter hole, and that's going to equate to 1.2 million litres a year. So I mean, you know, these figures are unbelievable when you work them out over a year. And if you get a 0.8 millimeter hole in your pipe, that'll equate to 280,000 litres a year. So that is just a fine mist spray, and you just wouldn't realise that is going to lose 280,000 litres per year. It's unbelievable when you think about it in those terms, you know.
I know we've done a presentation before on sort of water efficiency. We were looking at drip and taps, where like the drip out of a tap's about 0.25 milliliters per minute or something like that. And when you calculate that up over a year, it's something like 7,500 litres of water, which will cost you about 20 quid. And it's, you know, it doesn't, you know, you kind of see it, and people see it and think, oh, that's not going to equate to much. And it's not until you do the math and look at it and then kind of say, this is what this actually means, that people all of a sudden, you know, we did another one on sort of like brushing teeth. And, you know, if you leave your tap running when you brush it, if you do your 2 minutes like the dentists say you should, so please make sure you follow the NHS. You know, if you do that, it can cost you 30 quid a year just by leaving your tap running. That's one person. If you then get somebody else coming in, I've got 2 small kids who, you know, they can't be in the bathroom at the same time. You know, it could be costing me, you know, take me 120 quid a year just for people brushing their teeth, which, you know, just goes to show how important it is. And, you know, that again, you know, a tiny little leak like that, and you know, 280,000 litres of water it's a big chunk of water. Yeah.
People don't realise, Andy, because you know water's always there for them. It's just something that comes out the tap. People think there's no effort to get it there, and they don't realise what's behind it, and they don't realise the challenges water companies have of leaks and wastage, such as tap on while you're brushing your teeth. You know, it's an unbelievable amount of water that's wasted in this country. You know, so people should think about it.
Yeah, we'll get more efficient.
Yeah. Next, please, Andy. Oh, we're going to get technical now. So we're going to talk about correlation, which is part of what I used to do back in the day. So here you've got a correlator. This is a correlator setup, and this is what Andy asked about, how much they cost nowadays. So it's still the best method of locating leaks for commercial sites, really. This is a standard correlator set made by Halma Water Management, based in Newport, Wales. They used to be called Palmer Environmental. So here you've got 2 transmitters coupled with 2 very sensitive accelerometers, and these are very finely balanced magnets, so you don't want to knock them about in your van. We've got 1 base station as well. That's the blue part with the screen. Correlators work by magnifying leak noise, then analysing that leak noise in order to give a leak position. So these are highly sensitive pieces of equipment, and these basically narrow down and pinpoint your leak position on a pipe. So, you know, they've come a long way since their invention. If used correctly, Correlator will pinpoint all but the most difficult to find leaks, and correlation is based on 3 important parameters, which we'll look at next. Next, please, Andy. So you've got time delay, or TD. This is the time a leak noise takes to reach both accelerometers. If there is a time delay in the noise reaching one of the sensors, this is then processed with the Correlator software. Then you've got your velocity, which is your noise in the pipe, the speed of it. This is the speed at which sound travels within a water pipe. The velocity of sound within water is 1.4 meters per millisecond. There's 1,000 milliseconds in 1 second. So it's pretty quick. Next, please, Andy. So then you've got your distance. You know, a correlator is useless without a distance measurement to tie velocity and time delay together. So that's V times TD. Excuse me. The leak causes noise, which is detected by the correlators. The correlators measure the time taken to receive the noise and takes into account the time delay. So this allows the correlator to accurately locate the leak position. And there you've got your man there for the telly simples. So next, please, Andy. This one here is a 3-point correlator, and this is more up on the scale of what we were talking about, Andy. It's a bit more expensive because you can do more with one of these. You can also calculate the velocity of sound to gain a more accurate result. Velocity should always be calculated before correlation, otherwise you run the risk of a dry hole. It may sound unbelievable, but most leakage technicians don't know how to carry out a velocity calculation. The reason for this is that most companies involved in this service offering only send their technicians on the basic first training course, which only gives a basic understanding of leak detection techniques. So in my opinion, this is why there are so many dry holes within the industry. It costs a lot of money for companies. Obviously digging holes for no reason is going to cost a lot of money. So if there was more training, better training, the advanced correlation training for these guys, then there should be no reason for digging so many dry holes. Next, please, Andy.
So I suppose, Paul, when we're talking about the advanced training, I suppose that's something that you absolutely need for like commercial leak detection, because it's not just going to be a length of pipe that you know pretty much where it's going to be, because I mean a lot of the time there isn't any plans available, is there, for sort of particularly the kind of the private industry side of stuff?
Yeah, absolutely. On private sites, it's not like a water company. Private sites very rarely have plans of where the water mains are, so you're working blind. So really, you've got to know your stuff on leak detection. You've got to be trained really to be effective. You've got to be trained to advanced level on correlation techniques and leak detection techniques, because to put somebody out onto a private site with no plans, no help of anybody, to go and find a leak on a really big water network site, you know, it's going to be really difficult for that person. So really, you do need the advanced training. You know, it makes all the difference. And experience as well, Andy. You know, there's nothing like years of experience on private sites. So yeah. So this here, we've got a leak finder, the inventive name, leak finder. There's no technical time delays or velocity calculations. It's mainly for smaller pipe work up to 50 mil. It's an intrusive method, so you've got to cut into the pipe to use this. It works on air pressures and to locate, then repair leaks. This doesn't repair the leak, by the way. Somebody else repairs the leak. So yeah, the inventively named leak finder. I'm just going to read you a little sentence here. This product is ideal for pinpointing smaller leaks, such as a household supply pipe or small business premises. In fact, any pipe work up to 50 mil in diameter. Now, the manufacturers say it can go up to 63 mil, but as you can see on the picture, the little like terracotta coloured balloons on the inside the lid, they're actually rubber balloons, and they expand to create an air pressure gap in the pipe. Now, they say they go up to 63 mil, but I've never known one not burst, when you go up to 63 mil.
3 mil.
So I'd say don't use one of these over 50 mil pipe. That's pretty much standard. Next, please, Andy. Ultimate leakage control. So what's the most important bit? Well, you know, it's the technician. Whilst there are brilliant tools on the market to localise and pinpoint water leaks, there really is only one thing that matters to tie all this technology together: the highly trained, experienced technician. And that's me a long
I
time
love that
ago.
photo.
It's brilliant, isn't it?
You've
That was taken in Durham. That Dragonsville Industrial Estate, where we had a base set up there. But yeah, I think that's 1999, or is it 89? I don't know, but I look a lot better. I know that much.
You matured with age, mate. Don't worry about it. Like a fine wine.
So remember, it won't be the equipment that makes the mistake. It will be the partly trained technician. So invest in the experts, TWS. And, you know, this is, like I said, this is me. Oh, it's 1998. I've just looked at my notes. So I was at the time part of a team who set up Northumbrian Water's district metering areas. So that was encapsulating all the district metered areas so that Northumbrian Water could basically see how much water was going into each area. And we've done all the pressure tests and the flow rate and fitting meters, etc., and pressure logging, everything like that. So yeah, I'm quite proud. I helped set up all the district metered areas for Northumbrian Water, which I'm quite proud of. Any questions,
Okay.
anyone?
We're on to questions. Yeah, so we've had a couple come through. So basically, one of them that's come through says, I think I've got multiple leaks on my site. What would be the best way to locate them?
Multiple leaks. So if you're on a site, and obviously it's just not one piece of pipe, it's a site with its own sort of mini network, then you're talking about using a method called step testing to start with. And what that does is it's two pieces of equipment. One will sit in your van, and one will sit on your water meter. And what happens is you'll design a step test. So what you'll do is you'll separate out all the areas of the site that you can separate out through valving. And once you turn those valves off in certain areas in a certain sequence, you can have a look at the flow rates live from the meter. And once you've got the area of leakage valved off, then obviously your flow rate will drop right off on the meter. It'll tell you that instantly, and then you know what area you're looking into to take your correlator in and your other equipment. So to start with, it's called step testing, and the equipment's called a MAST, a mobile automated step tester. There you go.
I've got it on mute. Sorry, so the other one is, so, you know, we talked about different types of pipe. What would happen, because we have had it in the past, haven't we, where we've had like sort of a run of metal go into a run of plastic, etc. How would you get past that?
Yeah, so you're talking about mixed materials. Obviously, when repairs take place and, you know, things like that, some companies will put different materials in on the repair. So you could have, you know, 20 meters of metallic cast iron pipe, then 20 meters of plastic pipe, and then another 10 meters of cement pipe or something like that. So what you do there is you've got functions on your correlator that you can use, and you can use your time delay on that. So what you do is you check your velocity in the pipework, and that's done through a calculation on your correlator. So you can get that velocity of speed of the leak noise in the pipe, and then your correlator should give you an exact position of the leak, instead of, because if you don't do that, what happens is you could be 5, 10, 15 meters out on a correlation, dig a hole, it's dry. So yeah, you've got to be advanced level to know all this type of stuff, you know, but it's called velocity testing.
Another one that's come through is like, what's the biggest size clamp you can get?
Oof. Biggest size clamp. I think really it's just down to whatever size the pipe is, because we have companies who work with us that can actually fabricate anything we want. We have one in Jarrow, and we also have one on Teesside Industrial Estate near Thornaby. So whatever clamp you want, really, as long as we can get to the pipe, measure it accurately, then we can go away and get that manufactured.
Well, that brings us to the end of our questions. I'll just double check there hasn't been any more come through. So I guess we'd just like to say thank you very much for joining us today. We hope you found it informative. And obviously, if you do have leaks on your site, or you think you do, please do investigate. You're probably losing money at best. It could be damaging your property, and it's a precious resource. So if you do have any questions at all, or you want to ask Paul further questions, you can get us through our TWS email, so tws@nwl.co.uk, or you can ring 0800 028 3557, and if you press option 2, that'll get you through to Paul's team direct in case you've got any questions about leakage, leak detection, or repairs. Other than that, it's a big thank you from me.
And it's a big thank you from me.
Paul. Thanks very much, everybody.
Thanks, guys.